Alright, our Unit 2 video is on counting, chapters 4 and 5, permutations and combinations, and there were a lot of different things that we were introduced to in this unit. There they all are. Anything specific of note? I don't think so. Let's get into some examples. And again, we're stuck with the horse and buggy examples, but it's kind of fun, really. And there you see a typical example, and not very hard, but you got to remember how to do it, is to draw a tree diagram, right? So you'll have some situation where each of the possibilities leads to that many more possibilities, and we can show them on a tree diagram. Kind of a word of advice is the best way to do this is make sure that each level of your tree sort of lines up on a vertical line, otherwise it ends up being very difficult to follow your own work. And so in this case, open or closed, 1, 2, or 4 horses, and then for each of those cases, dressed or undressed, and I can see all 12 possibilities there. And that has there's the product rule for counting, and this is the and counting, right? So we got choices for open or closed, and choices for the number of horses, and choices for dressed or undressed horses, and so on. And counting means multiplying. We see there are 12 possibilities. All right, the next one. 8 prom-goers line up for a photograph. How many lineups are possible? And notice there's some key words there. Line up means that order is important, right? If I line a bunch of people up and switch 2 places, that's a different arrangement. So order is important here, which means this is a permutations question, right? This, I'm going to be using the P button on my calculator perhaps. So if there are no restrictions, and we're assuming that we can tell all these boys and girls apart, that they're not exactly the same, then it would just be 8 factorial, right? And that's some big number on your calculator. You pound that into your calculator, and you should get 40,320 just in passing. If we can't tell them apart, so if it was like 4 blue crayons and 4 red crayons, remember, identical items, we do this sort of thing. But in this case, they're not identical, so we're not using that counting technique. That's it for A. Should have a sentence there. I'm skipping that because we want to get through all these review videos. Second one, the picture must go male, female, male, female. So not a lot of formulas in this course at all, really. Well, lots of stats formulas, but as far as the counting part, the unit, this unit, not a lot of formulas. But there's some counting techniques, and one thing we do is we'd sort of set up a lineup like this. 1, 2, and went male, female, male, female, male, female, male, female. How many we got? 2, 4, 6, 8, and then that's it, right? 2, 4, yep, 2, 4, 6, 8. And so how many choices? Well, if it's got to go male, female, then there are 4 choices for that one. 3 there, 2 there, and 1 there. Well, how many choices for the females then? Well, it's the same thing, in fact, isn't it? Kind of a little bit of weirdness, but this is just 4 factorial times 4 factorial. Put that into a calculator and you should get 576. Another restriction, there are 4 couples, and the couples must be together. So one way to think of this is, well, let's put the couples together in boxes. That's kind of a weird thing to think, but where there's 2 spots in each of these boxes, right? So if I consider each couple in a box, well, there's 4 factorial ways to arrange the boxes, right? Well, this couple, there are 4 choices of couples. But then inside each box, it could be male, female, or female, male, right? So in each box, there are 2 possibilities. So for each of these choices, I'm also multiplying by 2 times 2 times 2 times 2 to the exponent 4. That is 384. What's strange about these counting problems, folks, is no matter how many you do, there's little twists and turns that you could be responsible for in the exam that you've never done a question like that before, and that's okay. I mean, part of counting problems are meeting new challenges, and if you do enough of these questions, enough counting questions, your tests over again and the review from the textbook should be enough. you'll be prepared. The next type of counting we had was Pascal's triangle, right? This idea, how many ways are there to travel from A to B, moving right and down? Well, this is a Pascal's triangle type question where you got to start there, no choice. How many ways to get to the next intersection? Well, there's one way to get there, one way, and I'm kind of going one block at a time or one intersection at a time. Well, how many ways are there to get to this intersection? Still only one, because I'd have to go right twice. This one, well, I'm not going to go up again. It says so there's only one way to get to this intersection, and I'm kind of moving out as I go. How many ways to get to this intersection? Just one. But here, there are two, right? Because I could go this way or I could go this way. There's two ways to get there. Two ways to get there. Only one this way. And now we're counting like Pascal, right? Pascal's triangle. And hopefully you're remembering this stuff, filling in the blanks. 1 and 2, 2 and 2, 1 and 3, and so on. There's little breaks in the picture which messes things up a little bit as far as the counting, but not the technique. 7 there, 7 there, 7 and 7, 14 here. Over here, 1 is straight down. 4 to get there, 1 to get there. 3 and 1, yeah. 4 and 1 is 5 to get there. Be careful now, because there's some weirdness going on here. There's still, like, I can't skip this here, so there's still only 4 ways to get to that spot right there. But there are 9 ways to get there. 5 from this way, 4 from this way, adding as I go. 4 and 14, 18, 9 and 18, 27. Pascal's triangle. Not a huge thing, but worth brushing up on, isn't it? The next one, typical exam question again. These Venn diagrams with 3 sets. When asked about the prom night activities, a sample of NWSS had the following report. So this is after prom. This is all what everyone did. And how we handle these Venn diagrams, remember, there's sort of 3 activities. And you kind of pick them out. There's people went on a horse and buggy ride. I'm going to call that set HB. Went out for dinner, I called that set B. Went to the after party, AP. And then I've got sets of people, right? So in each of these regions represents a different set of people. So how we do this is we start in the middle. 6 did all 3. And then we start working our way out. The next one, let's say here. Well, in here represent the people that went out for dinner and went to the after party. Well, 24 of them went out for dinner and went to the after party. Well, we've already counted 6 of them all. So I subtract off that 6 and I get 18 in there. And then I keep going. I can't get these 2 yet because there's these other regions here. 8 went on the horse and buggy and went to the after party. So that means there's 8 in here. There's only 2 here. Same thing there, 2. And I'm working my way out. 40 went to the after party. That means in this set here there were 40 people altogether, but we've counted 18 plus 6 plus 2 is 26 altogether. And there were 40 altogether, so I go 40 subtract 26 is 14. That just went to the after party. And if I keep going, I'm going to get my final answer. You can check this. This is 20 in here, 2 in there. And this question, this would be people who were surveyed out here that didn't participate in any of the activities, but that information's not there, so we can't add this. Notice that sometimes it will say something like 100 people were asked altogether. We'd have to add all these up and subtract it from 100 to see who didn't get counted. But that wasn't the case, so we're going to stop there. Example N, I think this is example 5. There are a group of 6 friends that are deciding if they want to go on a horse and buggy ride. Are you sick of the horse and buggy yet? Yes, we are. But oh well, let's keep on. How many ways are there for some of them to go? So for each of the 6 people, remember, each of the 6 people, they could either go or not. There's 2 choices. 2 choices for person 2. This is one of these, how many sets of people are going to go. So this is 2 to the exponent 6. But we subtract 1 because if some of them have to go, we don't want to count the empty set. So we're going to subtract the empty or null set. And so that's 63 ways for some of them to go. Question A. B. So now we know 4 of them are going. We don't know which of the 4, except for we know that Fredette will go only if Dreff does not go. That sounds like prom night drama if I've ever heard. So this sort of thing, there's a restriction. We kind of have to satisfy the restriction first. So Fredette, she can either, there's 2 cases, right? If she goes, we're going to include her, right? 1, choose 1. In this case, the order that they get on the buggy doesn't matter. Order's not important, right? It's just whether they attend or not. So this is a C question. And then that means Dreff can't go, right? So Dreff, there he is. Poor old Dreff gets left out rather. And now, how many are left over? Well, there's 6 friends altogether, and 1 spot's taken up already. So there's, how many is there? 1, 2, I guess there's 4 people left, and we have to pick 3 of them, right? So 4 people, this is to fill in the rest of the spots. That was our general strategy, right? Satisfy the restriction, fill in the spots. 6 people in total, 4 get to go. That's just 1 times 4 is 4 ways if Fredette goes. But if Fredette doesn't go, so that means she's left out. And then it doesn't matter whether Dreff goes or not. So then I just have 5 people, and I'm picking 4 of them to go, right? So how many ways are to do that? Fire that into your calculator, just think about it. 5 ways. So either she goes or not, 2 different ways. 2 different cases, rather. And that's exclamation, exclamation, not factorial, factorial, folks. Okay, that's it for the counting one. Just, a couple of examples. Not a complete picture of the counting unit, but a good sampling for the exam review. Next video is probability. It's probably probability.